This video is going to focus on how you can calculate unit rates given two quantities. Before we dive into this, we want to discuss what is a unit rate and, what are we doing when we find one? So a rate is when we have we're setting up a ratio of two different quantities. Miles and hours, pounds and people, dollars and pounds. Now, a unit rate is when the amount of one of those quantities is 1. So, for example, miles per hour is the number of miles you travel in 1 hour, miles per hour. Or dollars per pound would be the amount of money it costs to buy 1 pound of an item. So, when you're asked to find a unit rate, basically you want to turn your ratio into sort of a number per one of something. Now, we're going to look at sort of two general situations and then an application with this. In this first one, we're told that we have 5.6 pounds for 4 people. There's actually two different ways to find this unit rate. The first one would be number of pounds per one person, so pounds per person, or you could have number of people, and PPL is an abbreviation for people, per 1 pound, and LB is an abbreviation for pound. So we're going to try finding this unit rate using both rates and sort of look at the difference. So if I want to do pounds per person, I basically set up the ratio to be the number of pounds, that 5.6 pounds, divided by the number of people, the 5.6 or 4 people. And that, if you sort of think of it as like a fraction that needs to be reduced, I want to reduce it to where there's only one person on that bottom. And if you do that, you basically are saying, what is 5.6 divided by 4? And it happens to be 1.4. And so it's 1.4 pounds per person. Now, we don't typically write our unit rates this way. Instead, we'd write it as 1.4 pounds per person. If we then want to do the rate sort of the reverse direction, we want people per pound, that initial ratio, we're just going to set it up as its reciprocal. So instead of 5.6 over 4, we're going to do 4 divided by 5.6. And with the goal of getting us people per pound. And in this case, that would end up reducing to 0.71, yes, a fraction of a human, over that 1 pound. And so we could write that 0.71 people per, and I'm using a little slash mark instead of the word per, that's acceptable, pound. Probably in this case, it would be more reasonable to use that first unit rate over the second one, but it's good to have the flexibility in order to find both. So let's look at another example. This time we're going to be doing dollars and hours. So we have $95 in 5 hours. Like this would sort of be like earning money type of problem. And so the two options would be dollars per 1 hour, or we might have hours, the like amount of time it takes to earn $1. Let's look at the first one. So dollars per hour. So we're going to put our dollar amount over our number of hours, and that would reduce to 19 over 1 dollars and hours. And so we would write that as $19 per hour. And money is one of those few ones where we often put the unit before the number. That just makes more sense. Now, if we reverse that and we want hours per dollar, how long will it take to earn $1? I would have 5 over 95, which simplifies to 0.05 hours worked to earn $1. All right, so these were just examples where we found unit rates. Now, where are situations in which we might actually want to find a unit rate? And I'd say the most common instance is actually in the grocery store. If you take a close look at any of the price tags in your local supermarket, like your Fry's or your Safeway, you should notice in a little corner, it's going to give you a unit rate. It's going to tell you like how much money you're paying per ounce or per pound to buy that product. And I sometimes will actually compare those unit rates to think about what's going to be the bigger deal. Now, this is a calculation that you can quickly do on your own. And you sort of have to decide, what would you rather do, dollars per ounce or ounce per dollar? I tend to, when I'm looking for a better deal, I'm going to do the amount of money it costs per one of the weight measure. So in this case, we're looking at bottles of shampoo. And we're told that there's a 6-ounce bottle for $3.99. And then on the other hand, we have a 14-ounce bottle for $9.49. And so if we can figure out the dollars per ounce cost, then we can sort of figure out which is going to be the better deal. So let's start with this 14-ounce bottle. So I want dollars per ounce. An ounce is abbreviated OZ. So I'd take that $9.49 and I would divide it by 14. And I would find out that this is going to cost me about 0.678. And I know normally with money, we'd round to the nearest hundredth, but I'm going to keep that extra decimal place just in case these are super close. So it's like a fraction of a penny there. So that would be dollars per ounce for the first bottle, that 14-ounce bottle. And so then I'm going to do the same thing for my 6-ounce bottle. So I would have $3.99 per 6 ounces, and that simplifies to $0.665 per ounce. And if that's about 67 cents, and this is about 68 cents. So if I'm comparing the two, then I would say that the 6-ounce bottle is the better deal, because it costs less per ounce. So I could buy 2 of those 6-ounce bottles and it would, and then I have 12 ounces of shampoo. And yes, it's a little less than the 14-ounce bottle, but I'm paying less for that per ounce. So in the end, that 6-ounce bottle is the better deal, and that's what I'd want to buy. And so that's an example of where I want to find that unit rate to sort of be able to compare different sized objects. Stay tuned for the next video and where we look at taking these unit rates and then also combining them with some of our unit conversion problems.